Well, howdy everyone. How are you today? Hopefully you're doing well. As we continue on with our review of AP Calculus. This is starting my series of questions with differential equations in it. We're going all the way back to the 2014 test, and this is the 2014 question number 6. I do not believe you're going to get a question like this on this year's test. That's just a personal thought because a test that's online, I don't think they'll be able to give you graphs to do. But anyway, good to know how to do them, so it's good to review. For all the problems, we're considering this differential equation with the initial condition of f of 0 equals 1, and f is defined on all real numbers. Part A. Here's a portion of the slope field that is drawn. Sketch the solution curve through the point 0, 1. Well, the point 0, 1 is right here. So all they want you to do is kind of draw what the solution would look like. Just kind of follow along and give those. Doesn't have to be perfect, just has to be, pretty good. And, as I looked at this more, maybe I realized that this is, shooting up, then coming down. This looks like it might be going down a little faster and then coming up a little faster. But either way, a general curve like that, and you're all set. All right. Question 2, write the equation for a tangent line to the curve in part A at the point 0, 1. All right, tangent line. Remember, for a tangent line, you need two things. You need a slope, and you need a point. Well, how do you find the slope? You use your derivative. Hey, our derivative is right there. So all we have to do to find our slope is just plug in the value of 0 for x and 1 for y. So 3 minus 1 times cosine of 0. And the cosine of 0 is 1. So 3 minus 1 is 2. Your slope is 2. So basically, we're finding an equation that has a slope of 2 that goes through the point 0, 1. Oh, well, it's a little straightforward right here because we have our slope of 2 and our y-intercept is right here if we got 0, 1. So here's the equation of our tangent line. And we're going to use that equation to approximate f of 0.02. So all we're going to do then is we're going to put 0.02 in place of x. So we get what? 0.4, so 1.4. So we'll say f of 0.2 is approximately 1.4. Sorry, that was a little high. It looks like 0 times 2, but I meant 0.2. Okay. Alrighty. Last question. If you ever see on the test, if you see particular solution, differential equation, separation of variables, any of those keywords, you are just solving the differential equation. So in this case, our differential equation is dy over dx equals 3 minus y over cosine. So we must separate our variables. So I'm going to multiply both sides by dx. So cosine x dx are good. Now I get to get the y over here. And there is my equation. I have separated the variables. Now I am going to, once they're separated, I can now integrate them. So it would be the integral of 1 over 3 minus y dy equals the integral of cosine of x dx. All right, antiderivative of 1 over 3 minus y is natural log of 3 minus y, but be careful. If you take the derivative of 3 minus y, you get negative 1. So I have to put a negative out there to counteract that. Okay. The derivative of cosine of x, I'm sorry, the integral is sine of x. Our derivative of sine is cosine, so the antiderivative of cosine is sine, plus some constant. Now, you know me, I like to plug in the numbers right away so I don't have to deal with any crazy solutions for c. So right now, I'm going to let x equal 0 and y equal 1. So I'm going to end up with the natural log of 3 minus 1 equals the sine of 0 plus c. So I get the natural log of 2 whoops. I mean to change pens already. I'm right in the middle of that. Sine of 0 is 0, and I get c equals the negative natural log of 2. All right, good. So let me continue my separation. So we'll grab this one. All right. And we'll bring this down and we'll keep on separating. So in order to solve, I will take, well, I get rid of the negative first. So I'm going to rewrite this. I'm going to get the negative natural log of 3 minus y equals sine of x minus the natural log of 2. Well, I'll do everything with a negative. So we'll get 3 minus y, and we'll say negative sine of x plus the natural log of 2. And since the inverse is e, we'll do this little thing to it. So we get 3 minus y equals e to the negative sine of x plus natural log of 2, which means e to the natural log of 2. Okay, need a bit more room for this. These always are long problems when you separate and differentiate. All right, let me do e to the natural log of 2 is just going to be 2. And then I'm going to subtract 3. And one more step. Solve it for y. And there I have the particular solution to that differential equation. Historically, these tests, when they're graded, the separation of variables was always the most point per question. This particular question, part A was worth 1 point, part B was worth 2 points, and part C was worth 6 points. So you get points for separating variables, for integration, for using the plus C, for finding the constant, and for solving. So there's a lot of points there. So practice up on differential equations. Okay? And I will see you later. Have a good night. Bye.